morning students. So myself Dr. Ambarasan, Complete Department from St. Joseph Institute of Technology. Today I am going to see how to find the overall transfer function for the given signal flow graph. So this is one of the important topic in control system. So how to find the overall gain, you can say, or you can say overall transfer function, you can say. So it is one of the method in order to find the overall transfer function. So one more method we have already seen is block diagram reduction technique. So in the block diagram reduction technique we have different rules are there, but in this case we will have the using Mason gain formula. So it will be named as the scientist name is Mason. We follow the formula named as the Mason gain formula. So using the Mason gain formula we are going to find the overall transfer function. Okay. So here we have almost 5 steps we need not to find the Mason gain formula. Okay. So starting with the first step, step 1. So they given the signal flow graph as it is. In some problem they will give the block diagram. From the block diagram we have to convert it into signal flow graph. Okay. So in this problem they given the flow graph itself, but you have to note only what are the nodes. Okay. So start with the node, input, make it as a node 1, and next node here, and next node make it as a third node here, another branch point, and summing point wherever there. You can mention the nodes. Here we can mention the where are the joining points, we can make it as a node. And the final node will make it here, CRS. Okay. So here we have the different gain G1, G2, G3, G4, and we have the loops will be there, feedbacks will be there. Okay. So there will be gain will be there, negative gain also will be there. Okay. So in step 1 we are going to find what are the forward path gain. What are the forward path gain we have to find. Okay. You can see how many number of forward path is there. So normally the path can be found by the K. Number of forward path can be found by K. So you can see here what is the forward path. Forward path nothing but from the input R of S, the RMR goes to the output side. That is the forward path. From the input to output side, the RMR should be good. Okay. So for all the problems, there will be a central forward path will be there. There will be gain will be G1, G2, G3, G4. So always you can mention the first forward path is there, the first one. Similarly, is there what are the other forward path goes from starting point from here to the RMR goes towards the forward path. Like that we have to see the forward. We can see the G1. You see the RMR goes along the side. You can see G1, G2. From here we have the G6 is there. So we can take this forward path, but we can't do this forward path. So this is opposite side. Okay. So G1 we can't go minus G1. Similarly, you can't go G1 minus H3 code. You can't go for the forward path. Similarly, G1 minus H3 can't form the forward path. So only forward path. Straight line can have the forward path. Another forward path G1, G2, and the G6. So we can draw the forward path gain. So number of forward path is 2. Okay. So we are drawing the first forward path. Okay, with the node 1 G1, 2, 2 to 3 G2, 3 to 4 G3, and 4 to 5 G4. Okay. So this is CRS. Okay. So corresponding gain we are going to mention by relation to P1. Okay. So just to multiply all this gain value G1, G2, G3, G4. Okay. Similarly, second forward the what I told G1, G2, G6. Okay. Just draw the like this. Okay. Up to node 5. So this is 3. Okay. From 1 to 2, the gain is G1, and 2 to 3 gain is G2, and 3 to 5 downwards G6. So just to multiply G1, G2, G6 is another forward path. Make this as P2. So P2 is nothing but G1, G2, and the G6. So we got 2 forward path for the given signal flow graph. So this is the first step. We have found the number of forward. And second step, you are going to find how many number of individual loops are there. How many number of individual loops present on the given flow graph. So loops is something but closed path we have to find. So how many number of closed path? Okay. Step 2. Step 2, individual loop gain. Individual loop gains. Okay. So what are the loop gains? See here how many closed path. You can see here G2 minus H2. This is a closed path. The arm should be closed. It should be a closed path should be there. So you can see here G2, G3 minus H2. This is also closed path. Okay. And similarly you can see G2, G3, G4 minus H3. Okay. G3, G4. This G6 won't form the closed path. Okay. So the first forward path. So you can draw this one. So whenever we draw the individual loops, just to mark the nodes also, it will be easy to find the next step. Okay. So 2, 2, 3. The center forward path gain is G2. The feedback is minus H2. Okay. This is the first individual loop. So the corresponding gain just multiply both the G2 H2 minus. Okay. So I am going to mention this as P1 1. P1 1 as the first individual loop. Second individual loop. Just draw this G2 G3 minus H1. So this is the node is 2, 3 and the fourth node. So 2 to 3 G2 G3 and this is minus H1. Okay. So this is corresponding. So the second individual loop, that will be P2, and the individual loop I am going to mention by 1. Okay. So just multiply also gain minus of G2 G3 H1. Okay. So this is the second individual loop. Similarly, see the third one. Third one you can form this G2 G3 G4 next up to 5 minus H3. Okay. So starting with the 2, okay, 2 to 3, 4 to 1, and 5. 2 to 3 gain is G2, 3 to 4 gain is G3, 3, 4 to 5 gain is G4. The feedback is minus H. Okay, so the third gain, so can I have this step? So you can have the third individual loops G2, G3, G4 minus. So the third one individual I mentioned by 1. Okay. So minus of G2, G3, G4, H2. So this is the third one. Okay. Next one, fourth one, I am going to draw the fourth. So I will just place the first forward path and second forward path. Fourth gain, you can see the fourth gain, one of the fourth gain. So this is finished, one more gain. So this is also closed path. You can form the node 4 itself, you can form the fourth gain. So P4 1, you can write G4. There is only one gain represented as a G4. You can see another closed path, what are the other? So this is G2, G3, and this is finished, G5 finished, G3, G4. So you can form G3, G4 you can form. So we have to see what are most possible. You can see here G2, another G6 you can form. G6 and minus S. So this is not a closed path. Okay, this is not a closed path, but we can form this. Okay, from the second node 2 to 3, 3 to 5, then we will close it. Okay, so 2 to 5, 3 to 5 gain is G6, 2 to 3 gain is G2. So the feedback is minus H. So this is a final gain P5 1. Just multiply minus of G2, G6, H2. Okay. So these are the individual loops. So we have 5 individual loop gain. So if you want to easily you can mention. So individual loops P1 we have mentioned, P5, P2 we have find. Okay. So P1 we can find, we have found as G1, G2, G3, G4. Okay. And second forward path we have found G1 and G2 and G6. Okay. So these are the first step we have found individual loop gain. Okay. And next step we have found the individual loop gain. So you can write it here. P5 is minus G2 G6 H2. Okay. So these are the individual loop gains. So this is the second step we have found. And third step, from the individual loop gain, we are going to find sum of the product of two non-touching gains. Two non-touching gains. Gain product of two non-touching gain loops. This is somewhat different. So we have found the individual loop gain. We have found the individual loop gain such that we have found the pair. We have to form the pair such that these two not touch each other. These two nodes are touch each other. For example, we take this two pair. Okay. If we take these two pair, we have the 4. There is no node present on the 4 here. So we can form the pair lines. Okay. So first individual loops. Let me check P11, P21. G2H2. G2H2 is 2, 3 node. Okay. And P21 is nothing but G2, G3. Again, second node coming. So you can't form this two. This two we can't form the pair. Two not touching. Similarly, you can check 1 and 3. 1 and 3. Again, the second node will be repeated. So third loop we have is again second node will be repeated. We can't find this two also. 1 and 4. 1 and 4. 2 is there. Okay. 1 and 4 we can form. Okay. You can see that the first node, first individual loop is G2 minus H2. G2 minus H2 is this. 2, 3. This is G2 minus H2. Okay. And the fourth individual loop is G5. Okay. So you can see both the graph. There is no node 4 is not present here. 2, 3 is not present here. So we can form this two pair. Okay, this pair can be taken as a non-touching loops. This will be considered as a non-touching loops. Okay, so we can form P41 and P11. Similarly, we can check P11, P51. P51 again repeated. P51 is nothing but again second node repeated. Okay, so we have checked 1, 2, 1, 3, 1, 4, 1, 5. Okay, again checking P2, P3 you can check it. Again second node repeated. P2, P4 you can check. P2, P4 you can check. Again, second node we have the 2, 3, 4. Okay, but the fourth 4 is coming, so we can't form 2 and 4. Again, 2 and 5 also we can't form. Okay, so the only pair we can form the two non-touching loop is only one pair. So the third step is two non-touching loops. Third step is two non-touching loops. The two non-touching loops can be formed from the individual loops. Okay, so step 3 is gain product of two non-touching loops. Two non-touching loops. So this can be formed from the second step, that is the individual loops, such that these nodes are not touch each other. So only two individual loops which nodes are not touch each other is the first and the fourth. You can see here 2, 3 is there. Here 4 is there. Just to multiply both the individual loops, there is a gain product. Okay, so we can see gain product of another gain. So we have the first gain is G2 minus H2. Okay, again next gain is G5. Just to multiply all those gain, what is the answer? Will be getting minus of G2, G5 and H2. So this is the only one two non-touching loops present on the given signal flow graph. Okay. So third step, the two non-touching loops you can write T. So you can write T12. So you can assume this as T12. The two represent the two non-touching loops. Okay. So what is the answer? G minus of G2, G5 and H2. Okay. Similarly, in the Mason gain formula, there will be three non-touching loops present. Then we can check three non-touching loops is you can from the individual loops how three loops cannot be touch each other. So we can't form three loops. Three loops is 1, 2, 3. The three individual loops the nodes cannot be repeated. So in this problem we can, if we check the individual loops, there is no three non-touching loops. There is a three non-touching loop present means there will be a 4. Okay. So only we have the two non-touching loops corresponding gain is minus G2, G5, H. Okay, we got the two non-touching loops. So next fourth step, we are going to find the k represent 2. Therefore, we have to find del 1 as well as del 2. Del k represent del 1 and del 2 we have to find. So how to find del 1? Del 1 nothing but 1 minus r part of the graph which is not touch the first forward path. There is a first forward path is this is the first forward path. The part of the graph which is not touch the g1, g2, g3, g4. Is it possible? No. There is no graph which is not touch the g1, g2, g3, g4. All the graph which touch the this forward path. Okay. So 1 minus r the part there is no part of the graph which is not touch the center line. Therefore 1 minus r 0. So always the del 1 is 1 1. So for all the signal flow graph, almost all the graph will be touch the center forward path. That's why the del 1 is 1. You can see del 2 is nothing but what is the second forward path? G1, G2 and G6. So this is the second forward path. So we have to see 1 minus r part of the graph which is not touch the second forward path. Second forward path is this is the second forward path. So part of the graph we can form. Here there is a one more part of the closed path is there which is not touch the second forward path. So what is the gain corresponding gain? G5. So we have to subtract 1 minus r G. So del 1 is always 1 since all the part of the graph is touch the first forward path. Del 2 is 1 minus r part of the graph which is not touch the second forward path. That is 1 minus r G. Okay. So next we have to find what is the del. Del we have a formula 1 minus r sum of individual loop gain. Sum of individual loop gain. Sum of individual loop gain 1 minus again it will be plus sum of gain product of two non-touching loops. Sum of gain product of two non-touching loops. Again 1 minus plus again it will be minus will be coming. Sum of gain product of three non-touching loops. It will be repeated. There is no three non-touching loops. You can stop up to this. Okay. So now substitute the 1 minus r sum of individual loop gain. Individual loop gain is we already find P11, P21. We have to find individual loops. Just add. Okay. Sum of gain product of two non-touching loops. There is only two non-touching loops. Just substitute here. Okay. So you can find the del. So writing the del here. So del is so already I found del 1 is 1, del 2 is 1 minus of G5. Okay. So del is 1 minus of sum of individual loop gains. Minus G2 H2 minus G2 G3 H1 minus G2 G3 G4 H3 plus G5. Okay. Plus we have the only one again one more loop is there. So G5 plus minus of G2 G6 H2. So final loop is two non-touching loops. That is a minus of G2 G5 H2. Okay. Just take the minus inside. You can find it there. Then equal to 1 plus of G2 H2 plus G2 G3 H1 plus G2 G3 G4 H3 minus of G5 plus G2 G6 H3 minus of G2 G5 H2. So this is the del value. Okay. Now we are going to substitute all those things in the Mason gain formula. So last step, it will be step 5 based on gain formula. So we have start with the first step. We have found the number of forward path gain, and also second step we have found the individual loop gain. Okay. So this is the individual loop gain. So this is the forward path gain. Okay. So the third step we have found the gain product of. So we have to mention gain product, not two non-touching loop. Since we have formed a pair, from there we are going to product it. So gain product of two non-touching loops. So in order to find the two non-touching loops, So we have to see the individual loops. We have to see the individual loops. The individual loops should be drawn in terms of nodes. So without nodes, if we draw the individual loops, it will be difficult to find the two non-touching loops. So it will be easy in order to mention the nodes. Easily you can identify the which are the nodes which are touching each other. So suppose if there are 2, 3 is there means again 2 is coming means you can neglect. Okay. So to whichever the node which is not touch the another pair means we can find the game product of two non-touching loops. Okay. So we have found next we have found the del 1 del 2. Similarly mostly students will be find difficult in order to find the del 1 del 2. So it will be very easy. Del 1 make it as a 1 always. Why 1 is already told? Always the center part. There is no part of the graph which is not as the first forward part. So we mentioned 1 minus of 0. Okay. But in del 2, is there any forward path present? K equal to 2 means we have to check. What are the part of the graph which is not as the second forward part? We have to subtract 1 minus of corresponding graph. 1 minus g. Okay. Suppose the number of forward path is 1 means K equal to 1 means just put it is del 2 also. Del 1 alone. Del 1 means 1. Okay. So here del 1 del 2 we have found the number of forward paths. Next del. Del is the 1 minus of sum of individual loop gain plus sum of gain product of two non-touching loops again minus. So 1 minus plus again minus sum of gain product of three non-touching loops. It will be coming like this. Okay. So del we can substitute one individual loops you already substituted here. Again two non-touching loops you have substituted G2 G5. Okay. So we got the del. And finally we have the Meson gain formula. So when we ask in 2 marks also we ask what's the gain for Meson gain formula. Okay. So you can mention by transfer function T of S. Okay. So mostly what is the transfer? Overall gain is the transfer function. So how can you define a transfer function? So Laplace transform of output by input with the zero initial condition. So here the T of S nothing but Laplace transform output is C of S and Laplace transform input is R of S. Okay, thus we have found C of S by R of S. The S domain represents the Laplace transform of C of T. C of T, if we take Laplace transform, we will be getting C of S. And Laplace transform of R of T is input. R of S will be getting with the zero initial condition. So all the zero initial condition will be made as a 0 in the transfer function analysis. But in the case of state space, we will be assuming the initial condition and we will be solving all the things. Okay. And the C of S by R of S, the formula is 1 by del summation over the K Pk and into del. 1 by del summation over the K Pk del K. Okay. So if we expand, so K represents number of forward path. Okay. So T of S equal to 1 by del summation over the K equal to 2. K equal to Pk del. So K equal to 2 Pk del. Since this is a summation over the K. So if we expand the summation, K equal to 1, what is it? K equal to 2, what is it? Okay. Just substitute K. Okay. So K equal to 1, what will happen? P1 del 1. If you substitute K equal to P2 del 2. Okay. So 1 by del. Okay. Summation over the K. Suppose if the K equal to 1 means P1 del 1. Just stop it as it is. Here K equal to 2 is P1 del 1. So just expand P1 del 1 plus P2 del 2. Depends upon the forward path. This value will differ. If the K equal to 1 means P1 del 1. K equal to 2 means P1 del 1 plus P2 del 2. You can't do mistakes in this. Okay. Don't put P1 del 2 like that. So K equal to 3 forward path means P1 del 1, P2 del 2 plus P3 del 2. Okay. So now you can see here all these values we have found from the all the steps. The first step we have found the individual loops P1 to P2 already we have found. Okay. Del 1 del 2. So already we have found what is the del 1 value, what is the del 2 value. Del 1 is 1 minus of part of the graph which is not touching first forward path. Del 2 is part of the graph 1 minus part of the graph touch the second forward path. So del 1 is 1, del 2 is G5. Del we found 1 minus of sum of gain product. So from the individual loop gain you have substituted, two non-touching loops you have substituted. So substitute these values here. Okay. I'm going to substitute the T of S. What is the P1? P1 is G1, G2, G3, G4. G1, G2, G3, G4. Del 1 is 1. Okay, leave it up. P2 is G1, G2, G6. G1, G2, G6. And del 2 is 1 minus G5. 1 minus of G5. Okay. Whole divided by del value. So del value just substitute here. So what is the value? 1 plus G2 H2. Okay, plus G2 G3 H1 plus G2 G3 G4 H3. G2 G3 G4 H3 minus of G5 plus G2 G6 H3 minus of G2 G5 H3. So this is the overall transfer function. That is the Laplace transform of output by input. Okay. So we have got the answer. So we got the answer from the Mason gain formula. So we have used the 1 by del summation of Pk del T. Okay. So in the earlier method we have found the what is that block diagram reduction. Okay. So if they given block diagram means we have to convert it into signal flow graph. We have to convert it into what the question what you have given. In the signal flow graph we have to convert and we have to make the nodes. We have to write the nodes and then we have to solve the same problem. So whatever the method, either block diagram reduction technique or the signal flow graph, we will be getting the same answer. The question asks in block diagram reduction, when they are using the block diagram, we can identify by both the methods. Whether the same answer is coming from the both signal flow graph method or block diagram reduction technique. Okay, in block diagram reduction technique, we will be using the different rules. So in the rules, they may make some mistakes. But in the case of signal flow graph, we are using only single formula. That is the Mason gain formula. From that, we can analyze the transfer function. So this is the advantage over the block diagram reduction. So, and suppose if we do by the block diagram reduction, you will be moving some blocks from one branch point to another side or some point on the side. That will be some makes a mistake. But in the case of in this, what is the we have to check how many loops. That is the main thing. Majorly, we will be doing the mistakes in the individual loops. In the individual loops, suppose if we miss any one individual loops, mistakenly we are not seeing any one individual loops means again the final answer Mason gain formula will be different. So in this problem we have the 5 individual loops means you have to check whether maximum possible individual loops are there. Okay. And similarly 2 non-touching loops from the individual loops we can check from the nodes. The best thing, mark the nodes properly such that we can find the 2 non-touching loops. Okay. And del 2. So students, you have to mostly make mistakes in del 2. So how to find the del 1 always will be 1. Since there is a first forward path, there is always touch all the paths. That's why it is del 1 is 1. But in del 2 or in some case del 3 will be there, depends upon the number of forward path. And del 2 we can check whether the 1 minus of part of the graph is present means make less than 1 minus of G5. If there is no like this, there is no part of the graph present means del 2 also 1. Del 2 also 1. In some problem, we have to check whether 3 non-touching loops are present. That we have to be careful. Okay. So we have the 5 individual loops, 6 individual loops will be there. We have to mark the nodes. Check whether 3 individual loops which are not touching each other. We have to take the corresponding 3 loops and we have to product and type. So we have to make check whether the 3 non-touching loops are there. Okay. So other things it can be easy. There is same formula. We can make it from the individual loops and the sum of 2 non-touching loops and all will be you can find. Okay. So the final formula, keep in mind whenever they ask you 2 marks also, we have to write the corresponding values. What is the del formula? What is the k? Okay, k is the number of forward path, and what is the del k? What is the del k represent? Del k represent the 1 minus of part of the graph which is not touch the kth forward path. Like that we have to write. Okay, then we have to write the formula fully. Okay, so another thing compared to the block diagram reduction, we have to know what is the advantage of signal flow graph. Okay, so using the single formula itself, we can make easily can find the overall transfer function or overall gain. That is the C of S by R of S. block diagram reduction. So this is a transfer function analysis, and also we can have the one more analysis method for the control system is a state space analysis. So here the transfer function we are making initial 0, all the initial condition are 0, but in the state space analysis we are making the initial condition. So compared to transfer function, there is another method of analysis the system. Okay, I think it will be clear the signal flow graph very well. And same manner, you can use take any one problem, take the block diagram itself, just to convert it into signal flow graph, okay, and do it and see. And you can make use of both the methods. So do it by block diagram reduction tool, and also check the same problem by the signal flow graph method, whether getting the same answer. So if we get the same answer means, so we are doing in the right path. Okay. Is there any doubt we can ask?